Collaborative robots are starting to find their place in industry. One challenge these so-called cobots face is the communication of the robot state to the human. In general, robots can communicate via different modalities with the human user, such as acoustic, mechanical, and visual communication. We focus on robot-to-human communication via gestures. They do not require any additional hardware, are visible from different positions, and work regardless of the surrounding noise level. In this paper, we explore the intuitive understanding and user experience of zoomorphic gestures used to communicate the status of an appearance-constrained cobot. To investigate zoomorphic gestures in a benchmark with other visual communication modalities, we consider a collaborative assembly task. We designed the zoomorphic gestures based on the body language of dogs. For each robot state, we found equivalent dog behaviors to derive different gesture options, for example, prompting the user to take the acquired part. To teach the robot the different zoomorphic gestures, we used kinesthetic teaching. It allows natural flowing movements to make the gestures as dog-like as possible. We consider zoomorphic gestures, abstract gestures, and light displays in our proposed benchmark and examine their understandability and user experience. The benchmark considers the 3 modalities and 5 robot states. Overall, we created 3 design options per robot state and modality, which we evaluated first in a separate user study. The results indicate that there is a clear best option to communicate each robot state with a zoomorphic gesture. For abstract gestures and light displays, which do not have a natural semantic connection, the best design option is not as clear. Participants had strong associations of our zoomorphic gestures with dogs, although they were not informed about the connection to dog body language. For the other 2 modalities, the voiced associations support our underlying design guidelines. Based on the findings of the first study, we conducted a second user study to perform the visual communication benchmark. The results indicate that both zoomorphic and abstract gestures allow a significantly better intuitive understanding than light displays. Asked explicitly about their preference, more than half of the participants prefer the zoomorphic gestures. Overall, the user studies show that our proposed guidelines are suitable for the design of zoomorphic gestures. Further, zoomorphic gestures are more intuitive than light displays, and they are the preferred modality for robot-to-human communication. In the future, zoomorphic gestures could be used for a playful introduction for novel users and for customizing human-robot interaction.